Okay, we're going to cover the polynomial and rational inequalities. The biggest positive I can tell you about this assignment is that we're not graphing after the last few. Grab my pins that I've taken off. Let's just get started. Which of the following can be a test number for the interval? So this is one of those leading questions because we have to pick test numbers in all of our intervals for the next 9 problems. What they're saying is we need a number between -7 and 3. It cannot be -7 or 3 for when we're testing these later on. So a number that is between -7 and 3. -8 is less than that. 5 is greater than that. -7 is one of the test values. So the only one that actually works would be 1. That's very important when we're going through this lesson. So right here, first thing we have to do when we're doing these problems is find our zeros, and then we have to set up intervals, and then we have to test these intervals. So first thing, find zeros. We're finding our zeros. I kind of want to make that list somewhere. I just know some of these will take a lot of room. First, find zeros. Second, set your intervals. Third, test intervals. There's some of them we'll have to factor before we find our zeros, but that's part of finding the zeros. So here we go. Finding our zeros, we're going to take your 2 factors you have and set them equal to 0. So I'm going to have 4 and -7. So now that I have those, I'm going to go ahead because I'm going to need more room than I have on this little board. Our zeros. Oh no. Oh man. Wow. Okay. Once you have your zeros, set your intervals. So we're going to go from -infinity to +infinity, and you have to put them in order. So -infinity to -7. Now I'm not going to connect these. Then -7 to 4. And then 4 to infinity. Now when we test our intervals, we have to pick a test number. That test number is what that question 1 was about, where you pick a number that is in that interval that is not one of those outside numbers. You pick those outside numbers, you get 0. Because they are zeros. So we're picking a number in the interval that isn't the value on the outside. So this one, I like to stick to 10s, 5s, 1s, 2s, and 0. I like using 0. So I'm going to do -10 here. 0 falls in this interval, so I'm going to use 0 here, and I'm going to use 5 there. Once you have your test numbers, you take these values, plug them in, and figure out, this will change. Is it greater than 0 or less than 0, whatever they give you on it. That's what we're testing. We're testing to see if it's true or it's not. So here we go. Let's go -10 minus 4, and this is squared. -10 plus 7. Okay, -10 subtract 4 would be a -14 squared. And this is going to be -3. -14 squared, a negative times a negative is a positive, and that's going to be 196 times -3. Now right here, if you didn't know that's 196, that's fine too, because you know a negative times a negative is a positive. I need to know if it's going to be greater than 0. So if I know if it's negative or positive, that tells me if it's less than 0 or greater than 0. I don't have to know the specific number. So a negative times a positive is going to be a negative number. Is a negative number greater than 0? No. So this interval is not greater than 0. So it's not included. Then we'll do this one, 0, subtract 4 squared. So now I'm testing my second one with this test number that is in between this interval. 0 plus 7, and then 0 subtract 4 would be negative 4 squared, and this would be 7. Negative 4 squared is a positive, so 16 times 7. I don't know what that number is, but I know a positive number times a positive number. It's like part there. A positive number times a positive number is going to be a positive number. So this interval is going to be greater than 0 because it is positive. Now let's test our 5. So I'm going to have 5 subtract 4 squared and 5 plus 7. So 5 subtract 4 squared would be 1 squared times 5 plus 7. 5 plus 7 is 12. It's once you get to where everything's positive though, if everything's positive, it's positive. So if it's all positive, it's part of the answer. Type your answer in interval notation, simplify. So -7 to 4. And then we start over. On that answer, I use the union button. Kind of debating if I want to use the whiteboard for this lesson. Alright, first thing we do is find our zeros. So this one isn't broke apart like our other one was into our factors, so we're going to factor it. X cubed and x cubed subtract 3x squared. What we can take out of x cubed and 3x squared is x squared. And when I take 2 x's from x cubed, I end up with 1x. When I take those 2 x's from 3x squared, I end up with just 3. Then I'd find my zeros, so you set both of those equal to 0. And then you take the square root, so I'd have x equals 0. And here we add 3, and x equals 3. So those are our zeros. Once you have your zeros, you set your intervals. So my intervals, you start from negative infinity. And then our smaller one is 0. Then 0 to 3. And then 3 to infinity. Then we pick our test numbers for those. So numbers that are in the interval that are not on the end of it, because the numbers on the end are zeros and will give us 0. So I want to use -1 here, +1, and let's do 5. Once you have your test numbers, You plug them in. You can put it into this one or this one. If you're using a calculator, it might be easier just to plug them into this one. And then test it. So let's do... So -1 cubed would still be -1. Subtract 3. -1 squared is +1, so I'm going to have -1 minus 3, which is -4. Is -4 greater than 0? No. So that one's not in it. +1. 1 cubed, subtract 3, times 1 squared. 1 cubed is 1. Subtract 3 times 1 squared, which is 3 times 1. So 1 subtract 3 is -2. Is -2 greater than 0? No. Then let's use 5. This is going to be a huge number. 5 cubed is 125. And then subtract 3 times 5 squared is 25. So 125 3/4 is 75. 125 subtract 75 is 50. That's why I like to use numbers I can multiply with, but if you're using a calculator, go for it. Is 50 greater than 0? Yes. This is our only interval that's greater than 0, so that is our only answer. So much writing is included in these. I didn't mean to do that. But first thing we find our zeros. This one's a nice one. It's already factored out for us. So we're going to have x minus 3 equals 0, x minus 4 equals 0, and x minus 5 equals 0. The only thing about this one is that since there's going to be 3 zeros, we got a lot of intervals. And we're going to have an interval where we have to use halves. 3, 4, 5. Starting from -infinity and going to +infinity. I'll go ahead and write it like this. Mine are in order, so that makes it easy. And then I'm going to have 3 to 4. Then we're going to have 4 to 5. And then we're going to have 5 to infinity, because -infinity to infinity, and put them all in order. Alright, I'm going to erase this part and move the intervals up so I have room to test them. We got to pick our numbers that we can put in those to test it. Rid of that. Okay, so -infinity to 3, 0 is included in that interval. That's what I'm going to use here. You can't use 3, you can't use 4. You have to use a number that's between them. So I just go ahead and do that half. So I'm going to do 3.5 here. Same thing here. I need a number that's between 4 and 5, and I can't use them, so your other options are like 4.25, 4.75. Greater than 5, I'm going to use 10. I like using 10. You could use 6, 7, 8, 9, 10, 100, whatever. And let's test these. So here I go. I might have to erase each test as I do that so that they don't get too crowded on here. All right, so we have 0 subtract 3, 0 subtract 4, and 0 subtract 5. So I'm going to have negative 3 times negative 4 times negative 5. Negative 3 times negative 4 would be 12 times negative 5, which is negative 60. Is negative 60 greater than or equal to 0? It's less than, so this one is a no. And I'm going to go ahead and erase this so I still have room. And of course I hit something. 3.5, so I'm going to do 3.5 minus 3, 3.5 minus 4, 3.5 minus 5. So 3.5 subtract 3 would be 0.5. 3.5 subtract 4 is going to be negative 0.5. 3.5 subtract 5 would be negative 1.5. Now here I just want to use my rules of positives and negatives. So if I have a negative times a negative, that's a positive, and a positive times a positive means this is positive. Is anything positive greater than 0? Yes. So this interval will be included in our answer. I'm going to erase this so I still have room to work. Okay, 4.5. So we're going to do 4.5 minus 3, 4.5 minus 4, and 4.5 minus 5. 4.5 subtract 3 is going to be positive 1.5. 4.5 subtract 4 is positive 0.5. 4.5 subtract 5 is going to be negative 0.5. Same thing that I did on this one. I'm going to use my positives and negatives and the rules I know about those. Positive times a positive is a positive times a negative means this is negative. Is anything negative greater than 0? No. So this interval will not be included in our answer. Okay, and I'm going to erase this one. If you have a calculator, just plug it in and see what that value is. I'm doing this in my head, so yeah. 10 minus 3, 10 minus 4, 10 minus 5. So this is 7, 6, and 5. Everything's positive. So if everything's positive, it's going to stay positive. Is a positive greater than 0? Yes. So this one is also going to be included in our answer. So our answer is just going to be 3/4, 3 to 4, and 5 to infinity. 3 to 4. 3 to 4, and we use a union sign in this set if there's ever 2, and 5 to infinity. Three to 4 and 5 to infinity. Oh, okay, let me tell you what I did. We did all of our math right. Don't worry about that part. This problem has that greater than or equal to, and if you remember way back when, if it's equal to, we use brackets. So I need to change my parentheses with my numbers to brackets for my interval notation because it can equal 0. We just can't use those n values to test our intervals because we would get 0 and that would not work out for testing. So change them to brackets because it has an equal to. If you didn't catch that. Okay. I need to check our time because this one's going to take a second. Okay. So we need to factor first. The first thing I see when I'm factoring this one is that there's an x with all three of these terms. So I'm going to factor out an x. So I'd have x squared, subtract x, subtract 90 is greater than 0. Then I need to factor that trinomial. So I need factors of 90, numbers that multiply to get 90, that subtract to get 1, which is going to be 9 and 10. And since it's a negative 1, I'm going to need a subtract with my 10 and a plus with my 9. But now that I have it factored, I need to find my zeros. So I'm going to have x equals 0, x minus 10 equals 0, and x plus 9 equals 0. So and then I'm going to go ahead and get rid of this. I want to keep this in case I want to use it when I test my values instead. Then we'll get rid of, I'm going to get good at this in a minute. All right, now let's set our intervals. So from least to greatest, starting with negative infinity. The smallest 0 is negative 9. And then we're going to go negative 9 to 0. Then we're going to go 0 to 10. And then 10 to infinity. So now I don't need those guys. Why is that not greater than 0? Why did I write this so big? Alright, let's pick our test values for those intervals. Let's do negative 10 here. I want to use negative 1, positive 1. Since 10 is included there, let's do 20. We'll see. Okay, let's test. So I can decide if I want to use my factored one or this one. If I was using a calculator, which I'm not, but if I was, I'd probably just plug it into this, and whatever that number is it greater than 0 or less than 0? I'm going to go ahead and plug them into the factored one, though, because I'm doing it in my head. And I'll have to erase these as I go because it's going to take up way too much room. Okay. I'm going to have negative 10, negative 20, and negative 1. Negative times a negative is a positive. Times that negative, I'm going to have a negative number. Negatives are not greater than 0, so this one is no. I'm going to get rid of all this. Okay, negative 1. I'm going to do negative 1, then negative 1 minus 10. I'm just plugging these into it. I would plug it into the original one if I had a calculator. I feel like that would be easier. And you're less likely to make an error when you're writing it out like this. A negative times a negative, this is going to be positive 11 times 8, which would be 88. 88 is greater than 0, so this one is going to be one of our answers. Then I do 1 times 1 minus 10, 1 negative 9, and 10, this is going to be negative 90. Negative anything is not greater than 0, so this one is a no. And remember where that greater than and less than 0 is coming from is right here. Whatever that is, that's what I'm testing. So then let's do 20, and we're going to have 20 subtract 10, and then 20 plus 9, so 20 times 10 times 29. All really big numbers, all positive numbers. So my answer is going to be positive, and positive is greater than 0. So that is going to be one of my answers. My son's really been into pooping, and I just booped the smartboard. Help. 10 to infinity. Check that. -9 to 0, unioned with 10 to infinity. Okay. Next one. We're still good on time. These are so much writing. I'm really trying to make sure we don't have enough time. And I have to start one over. Okay. I have x to the fourth is greater than 100x squared. I want to get everything on the same side. So I'm going to subtract this 100x squared so that it's just 0 on the other side of our inequality. So when I test it, I'll probably test using this one. You can test either one, just remember that you'd have to do both sides. I'd go ahead and test it here. Oh, let's finish factoring it. X squared comes out of this, so then I'm going to have x squared subtract 100 is greater than 0. That's the difference of two squares. 10 times 10 equals 100. 10 subtract 10 is 0. They have different signs. Set your factors equal to 0. Solve each of them. Set your intervals, put them in order. Just try not to run out of room. Start with negative infinity. And go to positive infinity. I'm trying to decide if I want to keep all of these around. If I was y'all and using a calculator, I would test this one. I'm debating if I want to test with this one or this one in my head. But first, I have to set up my test intervals. So since I have negative infinity to negative 10, I guess I'll use negative 20. I'm going to use negative 1 and positive 1, and then we'll use positive 20. Here we go. I have to make my decision here. I'll do this one. Let's do negative 20. Remember, if you're typing in your calculator and it has that negative, be sure you put it in parentheses. I don't think Casios care so much, but a TI will do something completely different if you do not. So negative 20 squared is going to be positive 400. And so then I'm going to have 400 here, subtract 100. So 400 times 300 is going to be a positive number. That is going to be greater than 0. So this one is going to be an answer. Negative 1 squared. I'm going to erase this since I'm not using it. And then I'm going to have negative 1 squared minus 100. So this is going to be 1 times 1 minus 100, which would be 1 times negative 99. Is negative 99 greater than 0? No, sure not. Sure isn't. Sure not. 1 squared minus 100. 1 times negative 99. Nope. The thing about this one is since they're squared, it doesn't matter if it's negative or positive. They're going to match up. So I just caught where that video ended at the end there. the last thing I said was that they were going to match up. So then when I tested the 10, the 20 that was in my 10 to infinity interval, it was the exact same as that negative 20 and gave us the 400 times 300, which was positive, which was greater than 0. So our answer to that one was negative infinity to negative 10 union with 10 to infinity. Okay, here we have x to the 4th is greater than 1. The one I did yesterday was way harder than this one, so I don't really like this one. I'd move it all to the same side. So I have my 0. Then I would factor this. It's a difference of 2 squares. I think I'm going to blitz this one so I can get y'all one that's a little harder. So I factored this, but then it factors again because this one is still the difference of 2 squares. Then when I go to set my zeros on this, I'm going to have x minus 1 equals 0, x plus 1. And then here, this way back when we went over our imaginary numbers, this would only be an imaginary number. There's no real solution to it because when you take the square root of a negative, you get that I. So we don't use that. We're just going to use 1 and negative 1 for our intervals. So our interval would be negative infinity to negative 1, negative 1 to 1, and 1 to infinity. Okay, let's get rid of everything. Bring y'all up. Then I want to use, let's do negative 2, 0, and positive 2. Funky 0. I'm going to test it in this one because I only had 1 as my number, so I'm going to do negative 2 to the 4th power minus 1, and I'm testing to see if that's greater than 0, so negative 2 to the 4th power would be 2 times 2 is 4 times 2 is 8 times 2 is 32 minus 1 is going to be 31. That is greater than 0, so that is a solution. If I put 0 in, 0 to the 4th power minus 1 is going to be negative 1. So this one is not. Then I'd have 2 to the 4th power minus 1. 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is. So 32 minus 1. Why did I do 32? That's the 5th power. 16 is the 4th power, but 16 means this is 15. Getting carried away, y'all. So those two are our answers. I just wanted to get through this one because I think it's really easy and it's not fair for me to do the easiest example and you'll get one of the harder ones. Union with, I just want to grab a couple different numbers from a different example. All of them are going to be to the 4th power. And they're all probably going to be the same interval. But I don't like when I get the easiest one. Go away, things. Let me go back here. Let's get a similar question. 1 again? Are you kidding me? I don't even think anyone got 1 in my class yesterday. It's giving me the same one over and over. If I give you an example, will it give me one? So this one gave me 625. So that one is going to be 5 and negative 5 because the fourth root of 625 is 5. And so it'd be negative infinity to negative 5 and then 5 to positive infinity. But, yeah. Oh. Here, this one had a whole bunch of algebra with it. So, first we got to multiply everything out. Then put it all on the same side. Then find our zeros. Intervals, test intervals. Okay. I'm going to distribute the 2 on this side first. So I'm going to have 2x squared subtract 2 is greater than, I can't distribute this 3 first because this is all squared right here. So this x minus 2 squared means that there's 2 of these. So first I'm going to FOIL this. So I'm going to go ahead and rewrite 2x squared minus 2 is greater than 3 times x squared minus 2x minus 2x, negative times negative, plus 4. But then I'm going to combine like terms on the same side. No, not yet. Don't forget that. I'm going to distribute my 3. Then I'm going to combine. So I'm going to have 3x squared. I'm going to go ahead and combine these two though. Negative 2 subtract 2 would give us a negative 4 here. 3 times a negative 4 is going to be negative 12x. And then 3 times my 4 there is going to be positive 12. And then this one's not included in the parentheses, so it just comes down. Now I'm going to do 3x squared subtract 1x squared. And that's going to be 2x squared minus 12x plus 12. Whew. Now I'm going to put my 2x squareds on the same side since they're both the same. It's 0. There's no more x squareds. So I want to put all of my remaining stuff all on the same side. So let me rewrite that. I have negative 2 is greater than negative 12x plus 12. So I'm going to add my 12x over here. It's just going to move to the other side, and then I'm going to subtract my 12. So I'm going to have 12x subtract 14. It's greater than 0. But I can do one more thing because 2 goes into 12 and 14. So I'm going to factor 2 out and get x, not x, 6x subtract 7. It's greater than 0. Okay. I'm just going to write it up here instead of trying to move it all. So all of that simplified to that. That's what I'm going to use when I test it. All of this I'm going to erase because I don't have the room to keep it up here. Okay. Now then I need to find my 0. So I'm going to take these and set them equal to 0. Does 2 equal 0? No. So that doesn't affect us here. Equals 0. Add my 7. So 6x equals 7. Divide by 6. X equals 7 over 6. Right. Get rid of this. Keep you. Then my intervals, I'm going to do negative infinity to 7 over 6. And then I'm going to have 7 over 6 to infinity. Yes, the 0 is ugly, but that doesn't mean my test interval has to be. So 7 over 6, 6 over 6 is 1, so I can use 1 here and 2 there. I could use 0 here as well if I wanted to. Why not? So I'm going to take my test interval and plug it in here. My test interval, my test number, 6 times 0, subtract 7. So we're going to have 2, this is gone, times -7. 2 times -7 is -14. Is -14 greater than 0? No. No. Then we're going to do 2, and we're going to have 6 times 2, subtract 7. 2 times 12, subtract 7. That's going to be 2 times 5. 2 times 5 is 10. Is 10 greater than 0? Yes. That one is going to be our solution. Don't put your comment in the denominator. Infinity. Can I click it? Nope. Maybe I did. Okay. Okay. This one is like that fraction. Don't freak out because we've been doing this stuff for a long time now. You're going to set your zeros for this one, since it's not in the domain. It's still a 0 though. Set them both, the numerator and the denominator, equal to 0. So this one is 2. And this one's -8. Because this was our asymptote, but it's still an important part of this graph. And this one is our x-intercept, but these are both going to be part of our intervals. We used them in the previous lesson as well. When we were looking at those graphs, we'd split them up by the intervals, including the domain with the asymptotes. So intervals, -infinity to -8, then -8 to 2, then 2 to infinity. All right. Bye. Pull y'all up. And our test numbers, I want to use -10 here, 0's in this one, and let's use 5. We're going to plug them into that equation. I honestly think these are kind of easier. -10 plus 8 over -10 minus 2. And this one's a less than. -10 plus 8 is -2. -10, -2 is -12. I should say -10 subtract 2 is -12. A negative divided by a negative here, this is going to be +1/6. You can still type this in your calculator. If it's positive, is it less than 0? It is not. But 0 plus 8, 0 minus 2, that's going to be 8 over -2, which is -4. Is -4 less than 0? Yes, it is. But 5 plus 8, 5 minus 2, 5 plus 8, a +13, right? Over 3. That looks like I put a negative there. 13 over 3 is positive. Is that less than 0? No. So our only answer is that -8 to 2. Last one. Since this has a 1 here, you can't just solve it for your zeros because it all has to be on one side. once I work this, there's an easier way if you can just spot it. But yeah. I'd have to subtract it over. Now, you can't just subtract one from a rational expression. You have to have a common denominator. Our common denominator would be this x minus 13. So I'm going to have to change this right here to be x minus 13 over x minus 13, because anything divided by itself is 1. So what that looks like when I rewrite this and all of it's going to be over that common denominator now, because I changed my 1 to x minus 13 over x minus 13. So now they both have the same denominator, and I can combine my like terms on the top. So that's going to be x subtract x, which means there's no x on top, and then 12 subtract a negative 13. When you subtract a negative, you add it. So 12 plus 13 is, so this is, I don't want the equal sign, but I'm going to erase this stuff. But this is our expression now that everything is on the same side. And it's going to be greater than or equal to 0. Now that we find our 0, our only 0 is going to be that undefined part of our domain. So then we set up our intervals. I don't want to add it now because it won't be included. Now it will. Test numbers, I'm going to do 0 and 20. And then I'm going to plug it into this one. So I'm going to have 25 over 0 subtract 13, which would be 25 over negative 13. Which is a negative number, is a negative greater than 0. No. Then I'm going to have 25 over 20 subtract 13, which is 25 over 7. Positive is a positive greater than or equal to 0. Yes. But one thing on this one is that even though it has an equal to, we do not use a bracket only because that 13 would make it undefined. So it cannot be equal to 13 on this. So it's just going to be a parenthesis. Now what I want to tell you on this is that I'm debating it. You can avoid doing all the math if you just pay attention to what this number is, just to get through this problem without doing the rational expressions, because we haven't done a lot of rational expressions. But that is the last one in chapter 5. Yay.